Okay, welcome back. Okay, this is okay, welcome back. Remember, weight is a force and it's measured in newtons. Okay, so in the equation F equals m times a, weight equals the mass of an object times the acceleration due to gravity. Acceleration of gravity on Earth is 9.8 meters per second squared. Gravity is consistent on Earth since the Earth's mass does not change. Remember, your mass is too small to affect gravity between you and the Earth. Finally, Newton's third law. For every action force, there's an equal and opposite reaction force. Action reaction forces work on different objects, so they do not cancel out, okay? Because remember, balance forces were equal in size and opposite direction, so they sound kind of similar. Like it says action force, for every action, there's an equal and opposite reaction force. So the action force and the reaction force are equal in size and they're opposite in direction. So you gotta be careful, okay? Balance forces act on the same object. So like when we had those boxes, they were pushing on the same box from equal and opposite sides. But with these, they're acting on different objects so they don't cancel each other out. Okay, and we're going to take a look at some examples and see how they're not acting on different objects. Okay, they are not balance forces and they do not cancel out. And I want to take a look at this short segment on Newton's third law, and then we're going to come back and look at some of these examples. This little clip, we're going to take a look at Newton's third law. Now I want you to pay attention here, okay? The acceleration of the fuel is huge. The fuel is coming out of the rocket's engine, and it's accelerating a tremendous amount. But at the very beginning, the rocket's acceleration is small, but the mass of the rocket is ginormous, whereas at any given second, the mass of the fuel coming out of the rocket is small.
Come to Newton's third law of motion.
So force equals mass times acceleration. So the huge mass of the rocket times its small acceleration equals the small mass of the fuel times its huge acceleration.
For every action, there is an equal and opposite reaction. A rocket uses that principle to blast off of the ground.
So the equal and the opposite part is what I was just saying. The force of the fuel going down is equal and opposite to the force of the fuel going up. And remember, force is mass times acceleration. So even though at any given second, the mass of the fuel is tiny compared to the mass of the rocket, the acceleration of the fuel is huge. The acceleration of the rocket at any given second is small, but its mass is huge. So those two forces balance, and they're equal and opposite. Now, one of the other key concepts here is that they act on different objects, or they would cancel out because they're equal in size and opposite in direction. The fuel is a separate object from the rocket. So the two forces, the force acting on the fuel and the force acting on the rocket, are not acting on the same object. The force going down is the mass of the fuel times its acceleration. So it's the force is acting on the fuel. The force of the rocket going up is its mass times its acceleration. So it's on separate objects.
As fuel is burned and gases shoot out of the nozzle of the rocket engine, an opposite and equal force moves the rocket upward. Here is a cart containing a heavy metal weight and a strong rubber band stretched tight and ready for release. What do you think will happen when the string...
Okay, so the force on the rubber band is going to push the mass one direction, and then it'll be equal and opposite, push the car in the opposite.
That holds the rubber band is burned through. As you may have guessed, when the string breaks, the rubber band causes the weight to fly off in one direction, and the cart goes zooming in the opposite direction. These rocket cars are powered by CO2 cartridges. When the nail punctures the end of the CO2 capsule, CO2 gas escapes out the back. The cars go zooming forward. the cars move in an opposite direction than the escaping gas. You've experienced centripetal force and inertia if you have ever been on a
Now, remember we said acceleration is a change in speed or direction. So notice how many times this roller coaster changes direction and also how many times it changes speed.
amusement park rides like these. A roller coaster ride can carry you upside down or through a series of loops without ejecting you because of inertia and centripetal force.
Okay, so in this first example I've drawn over here, this picture of this rocket. Okay, so the action force is the fuel pushing down. The reaction force is equal in size in opposite direction and it pushes up on the rocket. Okay, so force equals mass times acceleration. So let's see how this works out on this rocket. Okay, the mass of the rocket, and I'm using a capital M, is huge. Okay, and it at the beginning includes the mass of the fuel. Okay, and we saw in that video when the rocket takes off, at first its acceleration is small. It looks like it's barely even gaining speed. Okay, so I put a little tiny a here. So the mass of the fuel coming out of the rocket, remember the rocket had the fuel in it, so at any given instant, the mass of the fuel is tiny compared to the mass of the rocket. So I'm using a little tiny m to represent a little tiny number. The acceleration of the fuel is coming out of there. It's just like, and we saw it's like it's going everywhere. It's accelerating out of there with a tremendous amount of acceleration. So I'm using a big A here. So when we figure out the forces, okay, the force acting on the rocket is its big mass times its tiny acceleration. And that's this reaction force. The action force from the fuel is the tiny mass of the fuel times its huge acceleration. So we got a big number times a little number, and we're saying that equals a little number times a big number. Okay, so what we're saying is the force of the rocket, the reaction force, its big mass times its tiny acceleration, is equal to the little mass of the fuel times its huge acceleration. So these forces are equal in size and opposite in direction. So we have the action of the fuel pushing down, and then we have the reaction makes the rocket go up. The same thing happens when you fire a gun. The action is when the gunpowder explodes and the bullet goes forward. The reaction is the kickback on the gun. Same thing happens when you use a hammer. The action is the hammer hitting the nail. The reaction is the nail pushes back on the hammer. Otherwise, the hammer just keeps going down. Okay. When you row or you push, the action is this man pushing with this stick. The reaction is the boat going forward in the opposite direction. Okay. When you walk, the action is your foot pushing backwards. The reaction is the floor pushing you forward. That's why you push back when you walk. Okay. We're going to leave off here. I want you to answer these questions alone. And when we come back next time, you'll answer these.